Hello everyone, my name is Aradhya Sharma and today I will be presenting a comparative study of two important machine learning classification algorithms, random forest and naive Bayes. Both of these algorithms belong to supervised learning and are widely used in real world applications such as spam detection, medical diagnosis, and fraud detection. In this presentation, I will explain how both algorithms work, their practical implementation using code, and also compare their performance. So let's start with the presentation. In this presentation, I will first introduce us to random forest, followed by naive Bayes, and then I'll explain their working concepts, compare their performance, and finally show a practical implementation using code. So let's move on to the random forest section. Random forest is an ensemble learning algorithm, which means it combines multiple models to improve performance. Instead of relying on one single decision tree, as in the case of decision tree classification algorithm, random forest builds many decision trees and combines their output to make a final prediction. Each tree is trained on a random subset of data, and each split considers a random subset of features. This randomness helps reduce overfitting and improves generalization. Finally, all trees vote and a majority prediction becomes the final output. To understand this intuitively, let's think of it that way. Imagine asking multiple experts for an opinion on a particular topic instead of just asking one. Each expert may make mistakes or have different opinions, but collectively, when they vote, they'll choose the most reliable answer. That is the entire point of random forest. Random forest uses a concept called Gini impurity to decide how to split data at each node. The goal is to create groups where data points belong to a single class. Some important parameters include number of trees, maximum depth, max features, and also minimum sample split. Here is a graph of showing accuracy versus n estimators. N estimators is equivalent to number of trees. So the more number of trees, the more the accuracy. Let's move on to naive Bayes. Naive Bayes is a probabilistic classification algorithm based on Bayes' theorem. It calculates probability of a class given some features. The key assumption here is that all features are independent of each other. This is why it is called naive. Even though the assumption is not always true, the algorithm works surprisingly well in many cases. If we look at the presentation itself, you can see the probability theorem, the Bayes theorem listed here, with each of its variable given here. There are four types of naive Bayes variants: Gaussian NB, multi-node NB, Bernoulli NB, and complement NB. So let's move on to the next. Let's see an example. For example, in spam detection, we calculate probabilities of words appearing in spam or non-spam emails. We multiply these probabilities and compare results. The class with the higher probability is selected as a prediction. Why naive? The algorithm assumes features are independent of each other. In reality, free and money are correlated in spam, but we ignore that. This simplification makes calculations fast and tractable. Works surprisingly well despite the assumptions being false, especially powerful for high dimensional data. Let's look at pros and cons. Random forest provides high accuracy, handles complex data sets well, but it is slower and less interpretable. Whereas naive Bayes is extremely fast and simple, but may not perform well when features are dependent. Random forest gives us high accuracy, handles missing values natively, it is resistant to overfitting, works for classification and regression, and provides feature important scores. It is slow to train, it is memory intensive, and it is extremely less interpretable as compared to naive Bayes. But it is still a better option for data with high dimensions or when the data is extremely tabular. Naive Bayes is extremely fast to train and predict, works well with small data sets. It cannot handle missing values, but it also handles high dimensional data well. It is easy to implement and interpret. great for text classification, and it struggles with feature correlation and has zero frequency problem. If we look at head to head, we look at the comparison here. We can see that random forest is extremely slow to train, has prediction speed of moderate, is accurate, extremely accurate, but in case of text, the accuracy drops a bit. Its interpretability is extremely bad, and its feature collation is handled well. It can overfit with small data sets, but it works extremely well with large data sets. It handles missing values natively, and its best use case will be tabular structured data. Whereas in case of naive Bayes, it is extremely fast to train, extremely fast to predict, and it has moderate speed in case of general and excellent speed in case of text. Its interpretability is high since it's probabilistic model. Its feature correlation, it kind of struggles in that. Small data sets, it works well with it. In case of large data sets, it's still faster and scalable. It can't handle missing data well, but it is best used in case of text, NLP, and spam filters. So let me bring you to the next thing, and that is the performance benchmarks. Here are the performance benchmarks for random forest and naive Bayes in each of these categories. Now, when to use which? I would choose random forest when you have structured tabular data, when your high accuracy is critical, feature importance is needed, and you have complex nonlinear patterns and missing values are present. I will choose naive Bayes when there are text and NLP tasks. Speed is essential, the dataset is small, and there are high dimensional features. Baseline model is needed. In these cases, I'll choose naive Bayes. But if you were to ask me that I need to give you a random answer, random classification algorithm, I first need to understand what is your requirement. If you require speed, I'll suggest naive Bayes. If you require accuracy, I'll suggest the random forest. You need to specify what kind of data set is there and what is your requirement for me to suggest accordingly. What are the key takeaways from here? Random forest is an ensemble power. There's many trees. There's a majority vote and high accuracy. It is robust and great for tabular data. Whereas naive Bayes has probabilistic speed. It is independence in assumption. It is fast, interpretable, and ideal for text. Neither is universally better, and they can complement each other. We can use naive Bayes as a fast baseline. Upgrade to RF if accuracy matters more than speed. Now, let's move at the Python demonstration. Here is my Python demonstration. In this implementation, I have created a dummy dataset with 5 features and a binary target variable. Each represents a data sample and the target indicates the class label. Now, let's see. We have imported pandas as PD, and then I have imported from sklearn train test split. This will help us to distinguish the data and train the models. Now, from sklearn.naive Bayes, I have imported Gaussian NB. From sklearn.ensemble, I have imported random forest classifier. Here's my data set with 5 features and a target variable. So I first import required libraries such as pandas and sklearn. Then I created a dataset manually using feature values and target labels. Next, I separate features and target variable. After that, I split the dataset into training and testing using train test split. Here, I initialize the Gaussian model. Then I train the model using the training data. After training, I make predictions as on the text data. Finally, I evaluate the model using accuracy and classification report. Now I initialize the random forest classifier with 100 trees. I train it using the same training data. Then I make predictions and evaluate performance. This ends my presentation, and thank you so much for listening to my presentation, and have a great day.